This meeting is being recorded.
In this last section from chapter 10, we're given a review of the reactions that are good to know. And that's what we're going to do here. We're just going to quickly review these three reactions that are radical reactions, which are actually synthetically useful. So these multi-step synthesis processes, we're going to apply these throughout the course. So it's good to get to know them now. So first we saw this in an earlier chapter, we saw this anti-Markovnikov addition when peroxides were present, but we didn't know that the peroxide was homolytically cleaved, and that would initiate a radical reaction mechanism. So that is why we have the least highly substituted carbon over here, which is brominated. Then we saw allylic bromination as well in this chapter, where N-bromosuccinimide was used to keep the bromine Br2 or HBr levels low in solution, so then we can have a more selective bromination of the allylic site here, as far as that versus bromination on the other side, right? So that would be another process through addition to a pi bond that we saw with HBr specifically. But for our radical addition, our allylic site would be the preferred site with NBS, but again, this undergoes a bromine radical that initiates this process. Then we have bromination of alkanes. So here our tertiary radical would be created. We use light in this case to create a bromine radical. That creates that hydrogen abstraction, so that hydrogen's removed, and then eventually we have bromination at our tertiary site. So you should know all three of these reactions and specifically how to predict products and locations of bromination for all three of these radical reaction mechanisms.